Hello, students. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4 on analytical geometry, and then this video here is compatible with both grade 11 and grade 12, so feel comfortable to watch all the way till the end of the video. And then we have ABC is a triangle with vertices A, 1:3, and B, T:0, and then C, P:4. Then we are told with P greater than 0, so P is a positive x coordinate. As we can see here, it is in the fourth quadrant where we know that our x values are positive. Then in a Cartesian plane, AB makes an angle of 45 degrees with the positive x-axis. So as we can see here, now that's what? That's an angle of inclination. If it is making an angle with the line, and then that we can see that that angle is starting from the positive x-axis and then going to touch that line. We know that that forms the angle of inclination because we can see it moving in that anti-clockwise direction. And that's one of the things that I hinted in my previous video to say that if you want to check the angle of inclination, you always have to make sure that it is going anti-clockwise. Then 4.1 says determine the gradient of AB. Now that we are given the angle here, the angle of inclination, we can see that for that 2 marks, this is the best way in which we can calculate that. We can just say tan theta and then equate it to the gradient of AB. So we'll be using the angle of inclination formula in order to find our gradient. Obviously, this formula here, the gradient formula, wouldn't work. And then why is it so? It's because we do not have the coordinate we do not have the complete coordinates for point B there. So we can see that we do not have the x coordinate, which is indicated as t. So even if we tried this formula here, it simply wouldn't work. But then now we do have another option in the form of the angle of inclination formula to just say, okay, now let's just say tan 45 degrees, and then that will be equated to the gradient of AB. Now tan 45, we know that's equal to 1. So that means, in other words, the gradient of AB is equals to 1. And then just like that, you've got your 2 marks. Then 4.2 says calculate the value of T. Now, the one way in which a lot of people would approach this would be to find the equation of line AB, since now you have the gradient. So let's take the method which a lot of people will be choosing to approach this question with. So you'd go y2 minus not y2, y minus y1. So we know of this formula here. Or if not that one, then you use the one whereby you say y mx plus c. Then with this one, you'd still have to find the point C, and then just like that. So same thing. So here, because for A, we have the whole coordinates, we can use those coordinates. That's y minus 3. And then our gradient is 1. And then here we have x minus 1. Right, so this will give us 1 times x is x, 1 times -1 is -1. So we have -1. If we transpose this -3, that's plus 3 there. Then y is equals to x, and then plus 2. So this would be the equation of the line. And then obviously to find the coordinate t there, which is the x coordinate, you'd have to now substitute the coordinates for b, which your y is 0. And then your x will be replaced by t, and then plus 2. So now your t would have to be equal to -2, right? So just like that, you would find your solution to a value of t. But then another way, so option number 2 would really have to be, okay, before I go to option number 2, let me just show you how you could calculate using this one. So with this one, you just go ahead and say your y is 3, still using the coordinates of A, and then your gradient is 1, and then your x value for A is 1. then plus c. So you get your value for c by saying 1 times 1 is 1. If you transpose it here, that's negative 2. So your equation again is x, not negative 2, positive 2 meant to say, because that's 3 minus 1. Then that will be x plus 2, right? Then again, you'd have to use this. That's 0, t plus 2, and then t is equals to negative 2, right? So this is just one option because it's just the difference in the formula that you choose to use. Now, option number 2 would be to use the gradient. So we know to calculate the gradient, that's y2 minus y1 over x2 minus x1. Now you'd say your gradient is already 1. So if you use these ones here, the coordinates, then your y2 would be the y coordinate of B, and then your y1 would be the y coordinate for A. And then I just like to follow it in alphabetical order, but then it doesn't matter which one you choose to make y2, which one you choose to make y1, as long as you follow through with that same order. So if you choose to make your second coordinate as B, then in all of that, in your x, this will have to be x2 and y2, and then this one has to be x1 and y1, right? Then your x2 would obviously have to be the t that you are looking for, then minus 1. Then at this point, we know that 1 is the same as 1 over 1, so we can just cross multiply this. This will be t minus 1, and then 0 minus 3, that's negative 3, 1 cross multiplied with negative 3, that's negative 3. Then if you say t negative 3 plus 1, from transposing this negative 1 over to the right hand side, then your t is just equal to negative 2. So this would be just the easier and quicker way to just look at it if you just try it with option number 2 using the gradient. But then remember, at the end of the day, there are too many ways to kill a cat when it comes to math. So just go with the approach that you understand most. Then 4.3 says calculate t, the x coordinate of point C. So we are given t here as the x coordinate of point C, but then how would we be able to calculate that? Reading from up here, we can see that we are given that AC is equals to root 50, right? So any information that we have there will be held will hold our analytical geometry question accountable for. Like when they arrest you and they say any information word. Then, okay, so now we have our AC here, our distance. So if obviously this one is hinting to us that in order to calculate our point P, we have to use the distance formula because we are given the distance between A to C. So we can say AC is equals to root x2 minus x1, then square that, plus y2 minus y1, and then also square that. Okay, so our AC is root 50, and then substituting these ones here, our x2, if we take the c here as x, the coordinates of c as the second coordinate, and this one as the first coordinate, then we will have p minus 1 square. Remember, we are taking the x coordinate first, and then coming with the y coordinates, I have negative 4 minus 3, right? So, okay, now at this point, we can see that what will actually hinder us into calculating is the fact that we have this in SAT form. So what we are going to do here is we're going to try to square both sides so that we get rid of that square root. So if we square both sides, these are the results. So we square both sides like that, and then we have 50 here. And then here, this will end up being t minus 1 square. And then here we have negative 4 minus 3, which is negative 7, but then negative 7 square, that's 49, right? Then at this point, we can see that if we can take the 49 and transpose it over to this side, that's 50 minus 49, which is 1. And then we have our p minus 1 square. Now at this point, what can we do? We can try to square both sides like this. And then we're going to end up with plus minus 1. Obviously, since this is inside the square root, then this will be p minus 1. Right. Now, at this point, remember they said that our p is in the positive axis. So this would be p minus 1 is equals to positive 1, or p minus 1 is equals to negative 1. So if we transpose the negative 1 over to this side, that's p is equals to 2. If we take this one and transpose it over to this side, then our p is just equal to 0, right? So obviously they said where p is greater than 0. So now we can see the importance of that statement. So p should not be equal to 0. It should be a value that is greater than 0. Then looking at this, we can see that our p is greater than 0 for when p is equals to 2. So therefore, our value, the x-coordinate of point C, p, is equal to 2. That's how you were just supposed to approach that one for 4 marks. Was pretty nice question there. Then let's go to 4.4. It says hence. So the hence part means that now that you have found whatever that you found in the above question, use that to calculate this particular question that you have here. So that's the hence part. So hence determine the midpoint of BC. So the midpoint of BC would be somewhere there, right? Now, midpoint, obviously, we have to use our midpoint formula. And then like that, so we have x1 plus x2 over 2. So you can see the formulas that you constantly need to remember when dealing with analytical geometry. That's your midpoint formula, your gradient formula, your distance formula, and as well as the angle of inclination formula, right? So make sure you always have those ones in your mind, right? So remember, we did calculate also the coordinates of point T there, and then we found that the coordinates for point T were negative 2. And then, okay, so now we just recently calculated that P is positive 2. So we can just use those ones there. And then our x1, if we take our x1 as that as coordinate for B, then that's negative 2. And then plus positive 2, then divide that by 2. And then here we will have 0 plus negative 4, then divided by 2. Now, at the end of the day, we find out that this one will just give us 0. And then here we will have our negative 2. So that means the coordinates for the midpoint are 0 to negative 2. So obviously, my prediction of the midpoint was not correct, because at the end of the day, remember, all these diagrams are not drawn to scale, right? So they're just only helping us to figure out the questions, but then they're not really drawn to scale. So if you were to look at it in terms of you want this line to be exactly symmetrical, then it would pose some kind of confusion as to why your midpoint is 0 is to negative 2. But your calculations are correct, and that's what it's telling you. So that's the correct answer. Then 4.5 says determine the equation of the line parallel to AB passing through point C, right? So they say determine the equation of the line parallel to AB. So this is AB, and then this line has to pass through C, right? So if we have to draw a line that will be parallel to AB, the line would look somewhat like that. But then this is not based on us having to actually draw that line. It's just a matter of understanding what happens to parallel lines. So if we are seeing this line here, let's call this line G, right, for argument's sake. Then if we have line AB being parallel to, so if we have line AB being parallel to line G, then what we know about the gradient is that the gradient of AB would have to be equal to the gradient of line G. Right? Because what do we know? Parallel lines have the same gradient, have equal gradient. Right? Then That means we do have that as part of the points that we have in answering this question here. Remember, the coordinates for C are 2 is to -4. So we already have the gradient from AB. So the gradient of AB, remember, it was what? It was equal to 1. So therefore, the gradient of line G also needs to be equal to 1. But then in order to find the equation, we know that we only need the gradient and a set of coordinates. We already have a set of coordinates because they said this line is passing through point C. So that means this line is touching point C, meaning that we can use the points C, the coordinates of C, in order to find that equation of the line. So we go with our straight line, equation line, and then there we go. So we have y minus -4. So that's minus -4 is equals to our gradient is 1, and then x minus t, which is 2, right? Then this, we have y plus 4. 1 times x is x, 1 times -2 is -2. So we transpose the 4 over to that side, that's x minus 2, and then minus 4. So our y is equals to x minus 6. Again, if you prefer this one here, whereby you need to first calculate your C, you can just go for it. So that means you'll have -4 here. Your gradient again is 1, but then your coordinates, your x coordinate is 2, and then plus C. Then for here, you'll have -4 minus 2. So your C is -6. And then you just go ahead and say your gradient is 1. So you have x minus 6. So either way, you would find that equation of the line that is parallel to AB. That's how you were supposed to tackle this question for a total of 13 marks. So with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.